Okay, I'm pretty sure this will be our last video on solving trig equations. Now, so far, what I want you to realize is all the trig equations we've been doing have just had one trig function. So we were solving simple equations like this, and a little more complicated, although not that hard, we did this one. We looked at what happens when you don't have just theta, but you have, so we did all the equations we've solved up until now have all had only one trig function. Now the last thing we have to look at are solving equations like this. So here's the first one we're going to solve. Sine of theta times tangent of theta equals sine of theta. So here, it turns out this equation has three different trig functions. So before I said the way we go about solving trig equations are you isolate the trig function by itself and then find the solution for the angle. Well, that assumes there's only one trig function in the equation. So what do you do when you have multiple trig functions? Well, most of these problems involve, we sort of do factoring. Now you're used to factoring maybe if I gave you well, that's not a good example. Let me just go ahead and do this. Normally when you factor, what you do is you get everything on one side. The way to solve equations by factoring is you get one side equal to 0 and get everything else on the other side. So here, I'm going to go ahead and subtract sine theta from both sides. So on the left-hand side, I have sine theta, tan theta minus sine theta equals 0. Now hopefully you remember in factoring, the first thing you always do is you see if there's a greatest common factor. To see in all your terms is there something in common. Well, I have two terms here, and it looks like both those terms have a sine theta. So I'm going to factor out the sine of theta and create these parentheses where I have tangent of theta minus 1. Now this is just like any other equation you solved in factoring. Once you have two things multiplied together that equals 0, the way you solve that equation is you take each factor by itself and you set it equal to 0. In other words, sine theta is going to be 0, and then I'm going to write over here the whole parenthesis. These are going to be my solutions. So now I'm sort of kind of back to the kind of trig equations we were solving earlier. So here, let's look at the sine of theta equals 0 first. I'm looking for an angle where the sine of that angle is 0. It only occurs once, right? Once on the unit circle. Actually, I misspoke. It occurs at 0. And I'm going to add the 2 pi in. And it also occurs at pi, right? So those are my two general solutions. If I want to get my specific solutions, so now n is 0, theta would be 0, and pi, when n is 1, both of these are over 2 pi. So actually there are two solutions, 0 and pi. And now, what about over here? Well, here I need to get the trig function by itself. So I'll add 1 to both sides. And now I ask myself, let's go find all the angles where the tangent is 1. Basically, that means where the sine over the cosine is 1. So it means where the sine and the cosine are equal, including the sine. And that occurs in quadrants 1 and quadrants 3. Quadrant 1, we have pi over 4, and then we add, actually, remember for tangent, I can just add pi n, and quadrant 3, 5 pi over 4 plus pi n. Of course, with pi n, these sort of repeat, so actually, I can just say pi over 4 plus pi n, and then if I go for my 0 to 2 pi, when n is 0, theta would be pi over 4, which is less than 2 pi. When n is 1, theta would be pi over 4 plus pi, which is 5 pi over 4, which is less than 2 pi. But when n equals 2, all of a sudden I'm bigger than 2 pi, so I stop. So it actually looks like I have 4 solutions if I look between 0 and 2 pi. All right, so that's sort of interesting. We had to actually factor the initial equation, and then we were able to solve it. All right, last one. This might look really complicated at first. 2 sine squared theta minus cosine theta minus 1 equals 0. It's like, wow. Now this is one where you have to sort of remember some trig identities, and the one I'm going to use is, this is the most commonly used trig identity. Sine squared theta plus cosine squared equals 1. See, the problem is, I've got sine here, cosine here, nothing factors, there's no common factors. I'm right sort of stuck. But then I say, you know, if I go over here and I realize that sine squared of theta equals 1 minus cosine squared theta, if I substitute that in here for sine squared of theta, at least then I've got an equation with only cosines, and then maybe I can do something. So let's go ahead and do that. So here's my 2. I'm going to substitute 1 minus cosine squared of theta, and then I've still got my minus cosine theta minus 1 equals 0. So now if I multiply out the parentheses, 2 minus 2 cosine squared theta minus cosine theta minus 1 equals 0. I can combine these. Minus cosine theta plus 1 equals 0. And now what I'm going to do is this is like a trinomial. I'm going to try and factor it, but I don't like this minus here. So let me multiply both sides by minus 1. So here's the equation we're going to try and solve. And if this is confusing to you, if you think about the cosine as like your variable, you know what this really is? This is really like factoring 2x plus x minus 1. In other words, think of that whole cosine as like your variable. The whole trig function is like your variable. Now, does this factor? Well, if I do product sum, my product would be minus 2. My sum would be 1. How about 2 negative 1? So the way I factor these kinds of problems So it's 2, -1. So 2 cosine theta plus cosine theta. That gets broken up. And now factor out the GCF. 2 cosine theta plus 1. Oh, this had to be negative right here. Sorry. I'm realizing I got a problem here. That's because this should be minus cosine theta, so it's -1. Up. Yep. Up. Nope. This is plus. That should be negative. So therefore, what I have left here is cosine theta plus 1. Then I have identical parentheses. So this is all just factoring. So this is all equal to 0. And now I've got 2 parentheses. I said each one equal to 0. Here's the first one. I'll do the second one over here. So here, cosine theta -1. Let's just do this to save time. Let's just do from the start between 0 and 2 pi. So from 0 to 2 pi, what angles is the cosine -1? Obviously pi. Over here, 2 cosine theta equals 1. Cosine theta equals 1/2. So I ask myself, on my unit circle, 1 trip around, where is the cosine 1/2? Pi over 3, 5 pi over 3. Turns out I have 3 solutions. Okay, that one was a little bit messier, but you may see problems like that. All right, so that wraps up solving trig equations.